Hey everyone, welcome back. This is James Brumfield. Today we're going to continue our binary search tree demonstration. And essentially, what we talked about last video, we talked a little bit what a binary search tree is, the three different ways you could traverse a binary search tree. And we start off with two classes. We start off with a node class, which is what I did all the work in last video, and a tree class, which is what we're going to work on shortly. And we also have our main method as well. So just to do a quick recap of what we done, we created our node class, and then we have three variables. We have a data element of type int, which is going to be the value of the node, and then we have two nodes left and right. Every time we call the constructor, we're going to initialize the data element here with the input parameter here. Now, most of the work last video was on this insertion method here. Essentially what this method is doing is we're comparing the value at the node to the value we want to enter. If the value is less than the value at the node, we're going to traverse to the left. If it's greater than the value at the node, we're going to traverse to the right. And we're gonna keep traversing until we find a insertion point. The insertion point is going to be when left is null or right is null. So just to step through the code really quickly, if the value we're entering is already a node, we're just going to just return out. We're not going to do anything. And if the value we're entering is less than, we're going to check over here if the node already exists. If the node doesn't exist, that's our left node. Same logic down here. If the node is greater than the value you want to enter and the node doesn't exist, that's our right node down here. Else, if the value at the left, if the node already exists, we need to determine where on the left we're going to insert it, because we know it's less than the node of the current node, and the same thing down here. So the reason we use a recursion call, because we need to keep traversing down the right side of the node until we find where this applies here. So that's why we do a recursive call. So for example, if we have 8 as our root node, then we have 10 as our right node, and then 5 as our left node. So say the fourth node we want to enter is 4. So 8 is less than 4 is less than 8, so we know we're going to go to the left. And then we also know 4 is less than 5. So this line here is we're going to keep calling this method, and it's going to keep running this logic above until we find our insertion point in which we can execute this code over here. And the same thing would go to the right. If we want to enter a node of 25, that's going to keep going to the right, and this code is going to keep executing. It's going to keep running this code above here till we finally determine when we could put a new node to the right here. So we'll see that in action shortly. So let's go out of presentation mode. We're going to start to populate our tree class. Okay, so in the tree class, there's really not much. Well, the first thing we need to do, we need a node. Let me go up. We need a node of type root. We'll call it root. So essentially, our first node we're going to create is going to be the root, but I'll do a method for that shortly. So we're going to create a method. So public void, we'll call insert node, which is different than the insertion method in the in my node class. And we're going to do insert a value. So first thing I'm going to do is check to see if the root exists. Tree is empty. If it's empty, that means there's no root. So we're going to say if the root equals null, we're going to create the first node that we're going to create is going to be the root. So we're going to say root equals new node of type value. So when we call this from the main method, the first one we're going to do, so as I was saying in early in this video, in the previous video, the first node we're going to create is going to be the root, and then we're going to call this method here. We're going to call this from the main class, and we're going to keep determining where we insert the new node, whether it be a left to the right. So essentially the way we're going to do that, so we're going to say find our insertion point. We're pretty much just going to keep calling that that insertion method that we did. So insertion value. So every time we call this method, we're going to call the insertion method, which is doing the majority of the work. We're going to call that from the node class. So that's essentially what we're going to do for now. So let's go back to the main method. Come on, stop. And we're just going to input some data. Insert main method. Let's go to main. Into presentation mode. Okay, so we're just gonna. I keep talking about 8, but let's see what we're going to enter. We're going to do. So let's add some nodes. Let's add some nodes. Let's do. Well, we need to create our tree first. So we're going to say tree. Let's call it int tree equals new tree. So we have an empty tree. So we need to, the first one we're going to do is going to be our root. So I'm going to say int tree. I'm going to call the insertion method from the tree class. Dot insert method. And let's do 25. So that's our root because there's no node that exists already. So let's do something greater. We're going to put, say 40. So say int tree, insert node. We'll say 40. So right node, right child, the first child. Let's do int tree again. Let's do 10. Let's do the value 10. It's the left node. So now, so essentially the first 3 is the root. This goes to the right, this goes to the left. I could, do a number 50. So this will be root. This will go to the right, and then this will, if this was 50, this will go to the right of 40. But we're just going to, and I'll probably do some test cases later. But we're just going to populate the tree for now. Insert. No, let's do 11. So this is 25. This is to the right. This is to the left. This is to the left. So this is the left right child. Entry again. I'm just going to, I'll just do this. Entry again. Let's do insert node. Let's do 8. This is the left child. Left child. Let's do a few more. Entry node. Dot insert node. Let's do 45. This is the right child. And let's do 1. So we got left, right, left. We need a right, left. So entry, insert. So we need, this is to the right, this is to the left, to the right, left. So we're going to use 35. Okay. So I'm going to pause this for 1 second just to show you what the tree is looking like. I'll be right back. Hey everyone, welcome back. I just want to pause it for a couple minutes just to type out this. So essentially, this is what our tree looks like. We have our root here. We call it an insert node method to 40. It checks the value against the root. It puts it to the right. Put left. It checks against this. Puts it to the left. We do 11. It checks 11 is here. Goes to the left. Checks 11 against this. Goes to the right. 8 checks it here. Goes to the left. Checks it here. Goes to the left. And the same logic applies for the right side of the tree as well. So essentially we haven't written these methods yet, but essentially we're going to do 3 types of traversals, which is what I showed in video 1. So essentially this is how, traversing is pretty much how we're starting at a certain point and we're going to different nodes and different edges and then we're going to print out the data element. So looking at this, in order pretty much means left, root, right. And this is pretty much going to spit out everything in order. So if you used to read up on binary search trees, everything to the left is always smaller, and everything to the right is always greater. So essentially when we start here, we're going to start all the way down to the left here. We're going to go 8, 10, 11. So we're going to go left, root, right. So that's going to be 8. I'll just do 8, 10, 11. Then it's going to go back up to here. I'm like, okay, we already been to the root. We're going to go up to here. This is another one, so it's going to go 25. And then it's going to go all the way down on the right side, all the way down to the left. So it's going to go 35, 40, 45. And as we print these out, you'll see this. So we'll go, what is it? So 25, 35, 40, 45. So pre-order, you're going to start at the root. You're going to start at the root, and then you're going to go down to the left and down to the right. And then post order, you start to the left, to the right, and to the root. So it'll go 8, 11, 10, and then it'll go 25, and then you'll start 35, 35, 45, 40. But we'll go more about those later. So this pre-order one is going to be 8, 11. This is what I think it is, but we'll see 8, 11, 10. Hold on. Right? Yes, 8, 11, 10, 35, 45, 40. Where's 40 at? 25. And then this one is going to be 25. Oh, sorry. This actually goes here. So root is 25. 10, 8, 35, 45, 40, 25. So I think that's right, but when we create the methods for this, we'll see. So before I end this video, I'm just going to do some quick work. So we'll just say sysout in order. What a traversal is, and we're going to create a method. I'm going to say entry. We'll call it in order. It doesn't exist yet. And then we'll do a new line. So essentially these videos, it pretty much forced me to really understand recursion. I really had to use the debugger to try to understand this. So we'll do in order, pre-order, and then post order. And then we'll say this is post order, and say this is pre-order. Okay, so I'm going to pause the video now, because I'm not going to have time to start these methods in the node class. But thank you for coming in, and I'm not sure if this is right, but we'll see in a second. We'll see. But anyway, thank you for stopping in. I'll be back shortly.